All right, so welcome back. We are doing lecture 6 of CS50 Introduction to Programming with Python. So lecture 6 focuses on file I/O, file input output. And cover the open command with command, look at CSV files, binary files, and pull, and summing up. So pull is images. So file I/O. Up until now, everything we've programmed has stored information in memory. That is, once the program is ended, all information gathered from the user or generated by the program is lost, i.e. it does not persist. File I/O is the ability of a program to take a file as input or create files as output. To begin, in a terminal, type code, names of Py, code as follows. Let's just copy this here. Is the name, let's use it, David, and there we go. Notice that running this code as a desired output, the user can input a name, and the output is as expected. However, if we wanted to allow multiple names to be inputted, how might we achieve this? Recall that a list is a data structure that allows us to store multiple values into a single variable. Code as follows. Notice that the user will be prompted 3 times for input. The pen method is used to add a name to our names list. So let's do David, James, Dora. That's it. Spaces are not necessary. This code could be simplified in the following by just using names of the pen and input that into this over here. So we can simplify it a little bit. Give us the same thing. Notice that this has the same result as a prior block of code. Let's run it again. So David, James, and Dora. This effectively stores this in the names list, and we can, visualize it or show it later on. Notice that let's enable the ability to print the list of names as sorted as follows. Okay, we can sort it as well. Sorted names. We'll move on. So we can say David, Dora, and James. Now it actually sorted for us using that built-in sorted method Python. And because all strings, it can do it quite easily, and James comes last. So, but this would still be in the same order that I created it. Let me just change this up a little bit. So, say this first say James, David, Dora. Yeah, so the previous one was actually the correct order. So now I just made the wrong order, and there it is. Let's run this one again. Gives the incorrect order. Oh, the order that's not sorted. Notice that once the program is executed, all the information is lost. It's true. File I/O allows your program to store this information later. If you switch off your browser, go away, this all data will be lost. Again, you can learn more about Python's sorted function over here. Go to Python's documentation. Open. Open is a functionality built into Python that allows you to open a file and utilize it in your program. Open function allows you to open a file such that you can read from it, or write to it. To show you how to enable file I/O in your program, let's rewind a bit. The code as follows. Yeah, let's code here. Let's see what's happening. Getting our name input. Now we are creating a file. We have input and write and close. So we are creating a file. We're opening a file called names.txt. Write a name to it and close it. Notice that open function opens a file called names.txt with writing enabled, as signified by the W over here. The code above assigns that open file to a variable called file, so assigns it there. The line file.write name writes the name to the text file. The line after that closes the file, writes the name and closes it. So let's, I'm not sure if this will actually run in Jupyter Lab because they're actually doing it as a Py file. Let's see. David. Let's see if it did actually do what I wanted. Oh, there we go. And you can actually do it in Jupyter Lab as well. And there it is. We created a file and there it is. How they wanted to do it, they wanted to create a file called, let's create a new Python file called names. Well, what do they want to call the file? Names.py. Oh, that's fine. Names.py. It's fine. And in this file, the same thing. So in this case, I'm just running the Python file this way. So I can say, run it here, maybe I can say send run names.py and Sedora or Joan chain. And what it does is it didn't actually do that because it already exists. So let's see if it overwrites it if I don't have it open. It's another possibility. Let's do Jane. See how Jupyter handles this. It overwrites it. And that is exactly what you should have seen. It overwrites it. This W is also used to overwrite. I use A to append. W would, right, but let's see what this is. Testing out your code by typing Python's name.py. You can input a name and save it as a text file. However, if you run your program multiple times using different names, you will notice that this program will overwrite name.txt file, which is exactly what you saw. Ideally, we want to be able to append each of our names to a file. Move the existing text file by removing names.txt in the terminal window. Modify code as follows. We don't actually have to remove it. Just change it to A for append. Notice that the only change to our code is that W has been changed to A for append. Running this program multiple times, you'll notice the names will be added to the file. However, you will notice a new problem. Okay, so I don't know what the problem is. Let's see. See David again. Once again, see James. Shift enter down again. And Laura. Let's see what problem. It appended it, but it did not add a new line during it. Next, try that. So examining your file, text file after running a program multiple times, you notice that the names are running together. Names are being appended without any gaps between each of the names. You can fix this issue again by removing an existing file in the terminal window, then modifying it by clicking the code by saying, this is a special F string, brackets, curly brackets, /n. Now let's see what happens. I have to close this. If you do not close it, it will not rewrite correctly. So let's do it again. David. So we get, there you go. David is correctly done. Next line, let's do or, and then close it. Or, and then here we go. So notice that the line file right has been modified at a line to a line break at the end of each name. The code is working quite well. However, there are ways to improve this program. So it happens that it's quite easy to forget to close a file. This line over here. You can learn more about this in Python documentation or PyOpen. The with keyword allows you to automate the closing of a file. Modify code as follows. So now The only difference is we're using the with command, replacing the file write, so the file closing, and creating with. With open, name file appended as file, and write file write in this code block. See, notice it is appended. Notice that below with, is it indented? Indented, correct. Up until this point, we have been exclusively writing to a file. What if you want to read a file? To enable this functionality, modify code as follows. So before we do that, let's just test it. Let's do John also fine. See if it works. Our code still works. There we go. John was added. Okay. So now let's leave that. Just remove this. Delete cell. All right. So now what we're going to do is we're going to read file. So what we're going to do is we're going to change this slightly. We don't need a name input, so let's just comment this out for now. And instead of names of text append or write, we're going to say changes to R for reading. And we're going to comment this out. We don't need it. And we're going to copy this line here, store the lines, and we're going to say file.read lines, which is going to store in lines, and then we're going to do for a line in lines, which creates a list. So this file read lines stores all the values as a list. So we're going to read each line. A list of lines. Say print hello line. Now, and when we get it read each line from the file and said hello to that name to each line. Pretty cool. Notice that read lines has the special ability to read all the lines of a file and store them in a list called lines. Running your program, you will notice that the output is quite ugly. There seem to be multiple line breaks over here. Here. There are many approaches to fix this issue. However, there's a simple way to fix this error in our code. We can use our strip as effect of removing the extraneous line break at the end of each line. So just have to say line strip over here. Well, actually, we're just adding our strip. And should fix it. There we go. Showing our strip. Removes the extra line breaks. So the code could be simplified even further. Sure, we can, instead of storing it as a list, we can just actively use it. So we can take this over here, basically code as is, and we say open the file with, using with, and then for each line in file, print hello, and remove the line break for that current line. So this one works. There you go, same result. Notice running the code it is correct. However, notice they were not sorting the names. Okay, let's take it further. Let's copy this list over here. And we're still reading in each line. And now we are going to store it in names. We're not printing it yet. We are going to store it in a list called names. And we're going to sort it and print it out again. There we go. Notice the names is a blank list where we can collect the names. Each name is appended to the names list in memory, and each name in the sorted list in memory is printed. Running your code, you will see that the names are now properly sorted. What if you wanted the ability to store more than just the names of students? What if you wanted to store both Miss names and the house as well? So CSV stands for comma separated values. Terminal window type code students in CSV. So I'm gonna new file, so students.csv, and we're going to copy and paste it. as is. I'm not sure you can actually do that. It's interesting. I'm not sure how to do that. What we can do is something like this, maybe. New text file. Students. A little bit hacky way, I think. So should move this one, delete it. I can't, it's still open. Okay, now delete it. Delete. Now basic contents. They want the contents of each person's name and then house. I'll save it. And now I rename it. And CSV at the end. A hacky way, but it should still work. There we go. Exactly correct. Okay, so we did that. So we create a new CSV file with the following comments. Now let's create a new program by typing the following. I'm not going to create a new program. We can just do it in Jupyter Lab. Makes it a lot easier. So let's copy this code and go through it. We have a with command that opens a file, opens student's CSV file and stores it as a variable file. And then your for loop for each line in file. Look at create a variable called row. And strip that line of any new line breaks and split that based on the comma, right? Split it based on the comma because a CSV file is separated by commas. And then print each row 0 is in row 1. So as in print each the name and the person, name and the house, I mean. So this would be, for this row, this would be index 0, index 1. For second row, this is row 0, index 0, index 1, index 0, index 1. That's exactly what it's trying to do. Run it and see if it is correct. Each person is named in their house. Again, notice that strip removes the end of each line of a CSV file. Split tells interpreter where to find the end of each of the values in a CSV file. Row 0 is the first element in each line of a CSV file. Row 1 is the second element in each line in a CSV file. The above code is effective at dividing each line or record of a CSV file. However, it's a bit cryptic to look at if you're unfamiliar with this type of syntax. Python has built-in ability could further simplify this code, modified as follows. Okay, so we can do it this way. So the only difference is we are storing each value separated into its own unique value, so name and house. So you don't have to work with lists, but variables. So this one and this one, this is quickly what you're doing. We should do the same result, and it does. Split function actually returns 2 values, name and house. Accordingly, we can rely upon that functionality to assign 2 variables at once instead of 1. 2 variables at once instead of 1. Previously, it was stored as a list. Now it's the list called row. Now it's stored in 2 separate variables. Imagine that we would again like to write this list as sorted outputs. We modify code as follows. Students equals empty list. Okay, let's copy and paste this. Only difference here is we are sorting it, right? Instead of printing out, we're going to store it as a list for students and sort it. And it is sorted based on first name here. Notice that we create a list called students, append each string to list, output a sorted version of a list. Recall that Python allows for dictionaries as well, where a key can be associated with a value. This could be further improved. See what we're doing now. So this is the same. We're creating an empty dictionary, storing the name in that key, name, same with house, and we append it to students. And then when we run it, when you print it, we are effectively looping through the student's dictionary and providing each output. Let's see what you get. Same result, but just different approach. Notice we create an empty dictionary called student. Over here, we add the value for each student, including name and house, into student dictionary. Then we append that student to a list called students. Append this to that. We can improve our code further to illustrate this as follows. So here we are just removing a few lines of code, but effectively doing the same thing. Run it to get the same result. So this line was replaced. Instead of having 2 lines to do it, just do it in 1 line. Notice that this produces the same desired outcome minus the sorting of students. Unfortunately, we cannot sort students as we had prior because each student is now in a dictionary instead of a list. It would be useful if a Python could sort the students list of student. List of students dictionaries that sorts this list of dictionaries by the student's name. To implement this, we can do this in our following way. This is all the same. Now we write get name function because this is not built into dictionary to do sorting. So we have to do this in a manual way. Create a function to get the name of the student. And then we call the sorted function. And based on students, we get the key name. We get the name based on the dictionary key. And then we put it out. We should get the same result. But is that sorted needs to know how to get the key of each student. Python allows for a parameter called key. We can define on what key the list of students will be sorted. Therefore, the get name function simply returns the key of student name. Running a program, you will not now see the list is now sorted by name. Still, our code can be further improved upon. It just so happen that if you are only going to use function like get name once, you can simplify your code in the manner presented below by modifying the code as follows by using a lambda, which is an inline, 1-line function. So this is a 1-line function called lambda. If you want to know, well, this is a keyword, which is a 1-line function, just to get the key name. So again, makes your code less lines of code. I still prefer having verbose code, so I still prefer this approach. But here, took this gives the same result as this. And notice how we use lambda as anonymous function. It says, hey Python, here's a function that has no name. Give the student access the name, return that to the key. Unfortunately, our code is a bit fragile. Suppose we change our CSV files as such that we indicated where each student grew up. What would the impact be of this upon our program? Let's modify it as follows. Create a new one. Oh, actually. Notice how running the program will produce a number of errors. Let's see what happens. Too many values to unpack. Now that we're dealing with homes instead of houses, the file goes as follows. which we've done. Notice that running program still does not work. So let's try this one, see if we get, again, error. The value error, too many values to unpack, produced by the interpreter as a result of the fact that we previously created the program expecting C file is split with commas. Now, not really the case. Could spend more time addressing this, but indeed someone else has already developed a way to parse that, and that is to read using CSV files. Python's built-in library comes with an object called reader. The name suggests we can use reader to read our CSV despite the extra comma, number 4 primitive drive. Reader works in a for loop where each iteration reader gives us another row from the CSV file. This row itself is a list where each value in the list corresponds to an element in that row, or 0. For example, first element of a given row, while row 1 is the second element. Let's try that. Code, so that. Importantly, we're using import CSV. If I handle errors better. There we go. Up until this point, we have been relying upon our program to specifically decide what parts of the CSV file are the names and what parts of the homes. Better design, but to bake this directly into a CSV file, editing as follows. Let's change that. Proper header, name, and home, rather. Notice how we're explicitly saying in a CSV file that anything reading it should expect to be the same name, value, and home, each value. We can modify code to use a part of CSV library called dict_reader to treat our CSV file even with more flexibility. Notice, so the main change was dict_read over here. Notice that we replace reader with dict_reader, which returns one dictionary at a time. Also notice that the interpreter will directly access the row dictionary, getting the name and the home of each student. This is an example of coding defensively. As long as the person designing the CSV file has inputted the correct header, mentioned in the first line, we can access that information using our program. Up until this point, we have been reading CSV files. What if you want to write to a CSV file? Again, let's clean up our files a bit. First, delete CSV. I'm typing remove CSV, CSV, terminal window. This command will only work if you're in the same folder. So we can remove it. Easier in Jupyter Lab. In students.py, modify code as follows. Typically, we're importing CSV, get to know name and inputs, and then create a CSV file appended, write the person's name. And using right row is what you use to write to the file. So we can say John. Let's see, that's right. There we go. And then helpful. We've created a CSV file. Notice that how we're leveraging the built-in functionality of dict_reader, which takes two parameters, file being written to, and file and field names to write. Third, notice how the write row function takes a dictionary as its parameter. Quite literally, we're telling the interpreter to write a row, two fields called name and home. Notice there are many types of files that you can read from, read and write. You can read from and write to. And learn more about this It's Python's documentation. Last section is binary files and Perl. One more type of file that we will discuss today is a binary file. A binary file is simply a collection of ones and zeros. This type of file can store anything, including music and image data. There's a popular Python library called Perl, works well with image files. Animated GIFs are a popular type of image that has many image files within it, played in sequence over and over again, creating a simplistic animation or video effect. Imagine that you have a series of costumes as illustrated below. Here's costume 1.gif. There's another one called costume 2.gif. Notice how the leg positions are slightly different. Leg position there, outstretched, this one's in up here. Before proceeding, please make sure that you have downloaded the source code of the files from this course website. It will not be possible for you to code the following without having two images above in a position stored in the IDE. Okay, let's download it, save it. Right, so I've downloaded two .gif files over here. And next one is to run these files, one's codes. I'm going to do this inside of Jupyter Lab itself. Hopefully this work. This index out of range. Why is it complaining? Image 0. Oh yes, I don't actually need the sys over here because I'm not going to input files in the same way. Jupyter Lab works a bit differently. So simple fix would just to use pull, it's fine. Images, I already know the file names. So I'm going to say for file name in costume 1 GIF and costume 2 GIF. Okay. This needs to be file name, so the same image, I think it's all the same. I think this should work. Does. And then costumes. Cool, you got a little GIF. Notice that when we import image functionality from Perl, notice that the first for loop simply loops through the images provided as a command argument. I did it as a list, because I know what it is, and stores them into a list called images. The one starts slicing arg at v. Again, we're not using argv, just using the normal list. Last time the code saves it. Let's go back to the code. So for loop to loop through all the images and then append those images into one list called images. Last line of code saves the first image and also pins it, creating animated GIF. Typing this into the terminal gives a GIF that moves, as we've seen over there. And you can see the animated GIF as well. And here's the, I think, duration is 200 milliseconds as far as I know. This is probably loop forever. Summing up, we have not only seen that we can write and read files, we can also read and write files using ones and zeros. Can't wait to see what you archive with these new abilities. Thank you very much. Until next time, goodbye.